Next, question number 6 of exercise 1.3. Look at several examples of rational numbers in P by Q form, where Q not equal to 0 and P and Q are integers with no common factors other than 1 and having terminating decimal representations or expansions. Can you guess what property Q must satisfy? So, they are asked to find the property Q must satisfy in P by Q form if P by Q, the decimal expansion of P by Q is terminating, isn't it? So, here given, if P by Q is terminating, we have to find a property that Q must satisfy. One thing is that Q should not be equal to 0. We know that. Then, what is the other? Is there any other property that Q must satisfy? In the exercise 1.3, in the first question, we have already gone through some of the questions. 36 by 100, 1 by 11, 4 and 1 by 8. In these questions, they are asked to find the decimal expansion, which kind of decimal expansion these have, this P by Q forms have. Here, we get 36 by 100 is equal to terminating. Then 4 and 1 by 8 is terminating. Then 329 by 400 is terminating. These three were terminating in this question. And by examining these three questions, we can see that these questions, in these questions, if the P by Q is terminating, that means the Q must be a power of 2 or a power of 5 or a product of the powers of 2 and 5. That is, for P by Q to be terminating, Q should be such that it should be the P by Q, P can be anything, then Q should be a powers of 2 or a powers of 5 or powers of 2 and 5. That is, the prime factorization of Q has only powers of 2, powers of 5 or powers of both 2 and 5. If Q satisfies this condition, then P by Q will be a terminating decimal expansion. That is, the prime factorization of Q has only powers of 2, powers of 5 or powers of both 2 and 5. You can check with this exercise question number 1 of the exercise 1.3, isn't it? So, going to the other next question. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. So, you have to write 3 numbers which are non-terminating, non-recurring. So, the easy way to write these numbers, that is non-terminating, non-recurring, is like this. Yes, it can be like this. 0.101000 1000 Look at this. It is non-terminating. It is non-recurring. It is easy to write, isn't it? And there can be like this. Let's put a 0 before that. 0.20 200 2000 20000 etc. Next, 0. Let it be 5. 50 500 5000 5000 etc. Isn't it? So it is non-terminating and non-recurring. You can write like this. This is a simple way to write like these questions like this, isn't it? The next question is, find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So you have to find different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So first you have to find the decimal expansion of 5 by 7 and 9 by 11. Let me do that. 5 divided by 7. 0.07 into 7, 49, remainder 1, it becomes 10, 7 into 1, 7, remainder 3, it becomes 30, then 4, 7 into 4 is equal to 28, remainder 2, it becomes 20, 7 into 2 is equal to 14, remainder 6, it becomes 60, then 7 into 8 is equal to 56, remainder 4, it becomes 40, then 7 into 5 is equal to 35, remainder 5. Here it's repeating, isn't it? So 5 by 7 is equal to 0.714285 bar. Next, 9 divided by 11. 0.08. 11 into 8, 88. Remainder 2, 20. 1, 11, 9, it becomes 90. Again 8, 88, 2, 0, 1, like that. Isn't it? So, 9 by 11 is equal to 0.81 bar. So, you are asked to write three different irrational numbers. What is irrational number? Irrational number is non-terminating, non-recurring numbers. Isn't it? It is non-terminating, non-recurring numbers. So you have to write three different non-terminating, non-recurring numbers between these two numbers. It's easy. That is 5 by 7 and 9 by 11. 5 by 7 is equal to 0.714285 bar and 9 by 11 is equal to 0.81 bar. So you have to write three non-terminating, non-recurring numbers between these two. I have already told you an easy way to write this non-terminating, non-recurring numbers. I will take any number that between these two, like here, I will take 0.75. 0.750, 7500, 75000, etc. Isn't it? Let me this be the first one. Second is 0.80, or I can 80 0 8000 800000, like that. Third one, I have to write in between like that. 0.77 7700 like that, isn't it? So you can write any number that is in between these two numbers. They just take it is 0.71 and it is 0.81. So you can write anything like this. 0.720, 7200, 72000, like that. Any number in between these two numbers, you can write that like this, and it will be irrational numbers. Just make sure that it is non-terminating, non-recurring number. Okay, got it?